Hello and welcome to our lesson on giant ionic compounds and metallic bonding. So far this unit we've been talking about bonding, and our first core concept is the knowledge that strong bonds need a lot of energy to break them. So what would you predict about the melting point and the boiling point of a substance that had a strong bond? Would it be high or would it be low? Well, if strong bonds need a lot of energy to break them, it will have a high melting point and a high boiling point. And that's because a melting point and a boiling point tells you how much energy or how much thermal energy you are putting into the substance. So the lot of energy, high melting point, lot of energy, high boiling point. Strong bonds means they've got high melting points and high boiling points. So let's look at the melting point and the boiling point of a couple of ionic compounds. They're pretty high. What does that tell you about ionic bonds? Well, they have high boiling points and high melting points. That tells us the bonds take a lot of energy to break them, and therefore the bonds must be strong. Another property we need to talk about is whether or not it conducts electricity. So what is electricity? Well, electricity is the movement of electrons carrying an electrical charge. So if electricity is going to flow, we need a particle which is free to move and to carry the electrical charge along the substance. This is either going to be an electron or it's going to be an ion. So if something conducts electricity, it must mean it has delocalized electrons or delocalized ions which are free to move and to carry an electrical charge. Now the word delocalized simply means they're free to move. If you look at these two diagrams that we've seen before of solid ionic compounds, does it look like they have any free electrons, or are they stuck in the lattice, stuck in the structure of that compound? Well, they're pretty stuck, aren't they? And this tells us then, if these electrons or ions are not free to move, then solid ionic compounds do not conduct electricity because there are no delocalized electrons, there are no delocalized ions to carry the electrical charge. However, if you look at this diagram here, you can see that the solid crystal structure on the left has no free ions, whereas the sodium chloride in this example in the water, you can see that the ions have actually split up and now they are free to move. Now this could happen in one of two ways. It could either be melted and turned into a liquid, or you could dissolve this ionic compound in a liquid or in water and you would get the same result. You would have ions that are free to move and carry the electrical charge. So liquid ionic compounds do conduct electricity. In our previous lesson, we looked at small ionic compounds made of just a few atoms ionically bonded together. But in reality, you can have many more. We talked about how the ionic compound is held together in that strong ionic bond because of the electrostatic attraction between the positive and the negative, pulling them together. But this electrostatic attraction of the positive is all the way around this positive ion, and the negative attraction is all the way around in every direction of the negative ion. So what actually happens, instead of having just one or two atoms, you have thousands, and what you get then is a much bigger molecule because every positive is attracted to every negative and every negative is attracted to every positive. So what you have is this giant ionic lattice where you have positive, negative, and so on. And this forms what we call a giant ionic structure or a giant ionic lattice. The giant ionic structures also have high melting points and high boiling points, and this is because they have extremely strong bonds. This ionic bond is extremely strong and there's lots of them. And so it's going to need a lot of heat energy, a lot of thermal energy to break those bonds so the bonds are strong. So moving on to metals then. So ionic compounds are held together with this electrostatic attraction between the positive and the negative. But metals are made of metal atoms. And metal atoms are all neutral, so there is no positive or negative charge. And metals all lose electrons and they all become positive ions, so positive next to positive, well, they should repel. So what is holding metals together? Because metals, as we know, they're solid at room temperature, they have high melting points, high boiling points, there is a strong bond going on here, but what is actually physically holding the metal together? So imagine then that this is an atom or several atoms of metal, and this atom is not stable, it doesn't have a full outer energy level, and the electrons in this outer energy level, well, they have a tendency to wander off. And if it wanders off, then what's left behind is not an atom, it's a positively charged metal ion because it's lost that electron. It doesn't just happen to one, it happens to all of them. So what we end up with is this, what we call a sea of delocalized electrons, free to carry an electrical charge, which is why metals conduct electricity. But then you also end up with all these positive ions because they are losing their outer electrons. Well, positive and negative, you're going to have a charge between them, or an attraction between them. So metallic bonds are between positive metal ions and a sea of delocalized electrons, and they're held together by this strong electrostatic attraction. Now, the strong electrostatic attraction is exactly the same strong electrostatic attraction that held the positive metal and the negative non-metals together in ionic bonding, but this time it's between the positive metal ion and the negative electron. So you've got to be careful with your language here if you're going to get marks in the exam. So make sure you understand the difference between the ionic and the metallic. Okay, so let's look at this information here. This is the sort of way it might be presented to you. You've got two substances and you've got some information. It says from the data below, suggest which substance is ionic and which is metallic and justify your answer. So substance A has a high boiling point, so it's got strong bonds. It conducts electricity as a solid and it conducts electricity as a liquid. And substance B also has a high boiling point, so it's also got strong bonds. It doesn't conduct electricity as a solid, but it does conduct electricity as a liquid. Well, I'm hoping that you would recognise that B is the ionic, and this here, the conducts electricity as a solid, no, and conducts electricity as a liquid, yes, is the dead giveaway, because this only happens in the ionic compound. So strong bonds, strong ionic bonds, given the high boiling point. It doesn't conduct electricity as a solid because it doesn't have any free ions to carry the electrical charge, but in a liquid it does have free ions to carry the electrical charge and therefore does conduct electricity. A, the high boiling point is because metallic bonds are extremely strong. It does conduct electricity as a solid because it has free electrons or delocalized electrons to carry the electrical charge, and it still has delocalized electrons to carry the electrical charge as a liquid, and so it also conducts electricity as a liquid. That's the sort of questions you might get. Okay, that's the end of that lesson, guys. I'll see you next time.